Hey girls, today we're starting chapter 8, which is all about polynomials and how it relates to the last chapter, chapter 7, which dealt with exponentials, is that we're still dealing with monomials, which are, as a reminder, numbers or variables, or they can also be a product of a number and a variable, and they always have whole number exponents. Only has one term, does not involve any division by a variable. So some examples include 5ab, 2x squared y, 3x. Those are all examples of monomials, whereas not monomials involve anything with a negative exponent or a fraction exponent. So that's how it's a little different from the last chapter. When you take a bunch of monomials and put them together as adding or subtracting, it becomes a polynomial. You might have learned that word mono and poly in other subjects, such as maybe like a religion class. Maybe you learned about monotheism and polytheism when you believe in one God versus many gods. So that can help you remember mono means one, so one term. Poly means many, so many terms. So it's many monomials together. The term is what means each separate monomial. So when you have a adding or subtracting sign, that splits up your terms. Whenever you have two terms, that's called a binomial. Three terms is called a trinomial. So one term monomial, mono means one. Two terms binomial, think like a bicycle has two wheels, bi means two. Tri, think tricycle has three wheels, so trinomial has three terms. In order to figure out the degree of a polynomial, that's when you look at the sum of the exponents of all the variables for one term. So for a polynomial, it's only going to be one variable, so you're just going to look at the highest power. Depending on what the highest power is or what the degree is, that's going to give you a special name for the polynomial. So if it's degree 0, meaning the highest power is 0, that name is called a constant. So an example would be like -8. Think of it as, you know, that's -8x to the 0 power. 0 power is a constant. It's never changing. It doesn't depend on the variable. Degree 1 is called linear. That's what our entire first semester was about. We know that's x to the first. So an example of a linear polynomial would be 3x to the first plus 1. You can have other terms in it. It's just looking at the highest power is a 1. Quadratic, which is the focus of this unit, is when you have a degree 2. So it's when the highest power in the whole polynomial is a 2. Cubic is degree 3. Quartic is degree 4. Quintic is degree 5. And when you go beyond degree 5, you just call it degree 6, degree 7, degree 8, or whatever the power is. Whatever the highest power is, I should say. All of these examples that I showed you for constant, linear, quadratic, cubic, those are all called standard form. Whereas quartic and quintic, those are not in standard form. Let's talk about what standard form means. Standard form is how you have to write a polynomial when you put the terms in order from the greatest power down to the least power. You can put the terms in any order. Like this quartic example, it's in any order we want. We have the 4th power, the 0 power, then the 1st power. The quintic example, we have the 5th power, the 0 power, the 1st power. That's why those are called not standard form, because they're not in order from highest power to lowest power. Once you have the polynomial in order from greatest power to least power or highest power to lowest power, you can tell the leading coefficient. That's the coefficient of the first term when it's written in standard form. So you have to put it in standard form first, then you can tell the leading coefficient. The leading coefficient is really helpful. You'll need to know what the leading coefficient is because eventually you'll learn something called the leading term test, which is based on the leading coefficient. So just know the leading coefficient, you have to put it in standard form, and then it's the first coefficient in standard form. Now we're going to take a look at some examples of identifying polynomials. So let's do some together first. We're going to fill in this table. Here are some expressions. We're going to go over, is it a polynomial or not? The first one, 4y minus 5. You know that that's y to the first power, so it is a polynomial because 4y is a monomial, negative 5 is a monomial, and then there's just two monomials together, so yes, and specifically it's a binomial because there's two terms. It's degree 1 because the highest power is a 1, so the special name for degree 1 would be linear. The next one is negative 6.5. Technically, that could be written as x to the 0 power because we know x to the 0 always makes 1. Negative 6.5 times 1 is still going to be negative 6.5. So technically, that's the same thing. Is that a polynomial? Yes. It is just a simple monomial, one term. Degree 0 because the highest power is a 0, which means the special name is a constant. The next one, however, 7a to the negative 3 plus 9b is not a polynomial because 7a to the negative 3 is not a monomial. Remember, we said you can't have any negative exponents in a monomial, and in addition, it's two variables. So you won't have to put a degree or a special name because it's not a polynomial. The next one, 6x cubed plus 4x plus x plus 3, it is a polynomial. So you can say, yes, it is a polynomial. How many terms are there? There are 4 separate terms here. And it's degree 3 because the highest power is a 3, which means its special name is cubic. Now let's look at taking these polynomials and putting them into standard form. Once you put it in standard form, you want to identify the leading coefficient and the degree. So let's say we were looking at this polynomial. We already are telling you it is a polynomial. It's 3 separate terms. The plus and minus sign separate the terms. Just like in a linear equation, the plus and minus signs separate the two terms. Now you can have more than 2 terms though. This one is 3 separate terms. So its special name is called a trinomial. In order to write it in standard form, you're going to check which one of those 3 terms has the highest power. The 4x to the 5th has the highest power, and it's positive, so you're going to put that first and keep it positive. The next highest power is the 3x squared. Since 3 is positive, you're going to put a plus sign in front of it. You have to separate your terms with a plus or a minus. The last term is going to be this minus 7x. You have to keep the minus in front of the 7x. Once you have it in standard form, the leading coefficient is just the first coefficient, so 4. And the degree is just the highest power, which if it's in standard form correctly, should be the first power, so degree 5, which is called quintic. Now let's look at one more. This one has 4 separate terms. The highest term is the 2y to the 4th, but it's negative. So you have to put that negative in front of the 2y to the 4th, so you keep it negative 2y to the 4th. The next highest term out of all 4 of those is the negative 6y cubed, so that goes next. Then the positive 5y, then the minus 9. So it's in order from the highest power down to the lowest power. Now that it's in standard form, the first coefficient is called the leading coefficient. You can abbreviate that if you'd like, and it's a negative 2. And then the degree is the highest power, which should be first in standard form, degree 4. Its special name would be quartic. Now I want you to try some of these on your own, so go ahead and pause the video and then see if you got these answers right. And then that's all I have for you guys today. Next, we're going to look at adding and subtracting polynomials in the next lesson. Bye, guys.